We are now going to solve these simultaneous equations, but we're not going to do them graphically this time. So you'll notice last time we graphed them, but we used the intercept and the gradient, and we didn't use the table of values, so we stepped up our game. This time we're going to do it by substitution and do it algebraically. We're not going to use graphs at all. Now, this can be both easier and more difficult, depending on how you feel about algebra. But we're going to go through this, and I think you'll find that it's much easier than having to draw the graphs. So what we've got is we've got two equations. We've got y equals 2x plus 3, and we've got y equals minus x. So you'll notice that I've rewritten them, and I've rewritten them underneath each other. The next thing I'm going to do is I'm going to name these or number these. I'm going to call it equation 1 and equation 2. Now, we've been given a specific process that we're going to follow. Now, there are two different ways. You can either use elimination or you can do substitution. So we're using method 1, which is substitution. It does give you some instructions on how to do it. I'm not going to worry about them at the moment. I'll go through them in class, but we're going to do it now. So what we're doing is we're going to substitute one of these two into the other, and it will help us eliminate one of the pronumerals. So what we want to do is either get y equals or x equals, or equals y equals x, you know what I mean. But we want to get down so that there's only one pronumeral. So hopefully you're looking at this going, well, I can see a way that I can get rid of the x's or I can get rid of the y. Okay, so we're going to use substitution to do this. And the way I'm going to do it is I'm going to take equation number 2 and put it into equation number 1. Where am I? No. What I'm going to do, now thinking about it and not being half asleep, is I'm going to take equation 2 and I'm going to substitute it into equation 1, which is exactly what I said, but now I'm thinking about it correctly. So what I'm going to do is I'm going to sub equation 2 into equation 1. So I am writing this down, and I expect you guys to write this down as well. So everything I've written thus far in green and red, you should write. Okay, so I'm going to sub 2 into 1. Now, the reason I'm changing colors is just so you can see what's an instruction and what is the actual working. So what do I mean by sub 2 into 1? Well, at the moment, I've got both of these. I have y equals. So equation 1 says y equals 2x plus 3. Okay, that's all well and good, but I'm going to sub equation 2. Now, equation 2 says y equals minus x. So what I'm actually going to do is I'm going to say, all right, well, that means in this equation, I have a y, and I know that y equals minus x because it says it in equation 2. So I'm going to replace my y and go minus x. So what I've done is I've actually taken it and I've gone, right, I now have gotten rid of one of the pronumerals. I've gotten rid of the y. And I did that by just substituting in because I've got down here that y equals minus x. Now, the reason that this works is we're solving them simultaneously. So we're trying to find where both of these exist. And if both of them exist in a particular spot, that means they are both true. They will both work. So whatever value I put in for x will give me the same value for y. So this is why it works. So we've now subbed 2 in. We've subbed 2 into 1. So we've got minus x equals 2x plus 3. So now we're just going to rearrange it until we get x equals or equals x. So at the moment we have minus x on one side and we have 2x on the other. So I'm going to get rid of, if I change colors again, I'm going to get rid of the 2x from that side, and I have to take it away from that side as well. And that will get rid of it from the right-hand side. So minus x minus 2x will give me minus 3x. Those cancel out, and I'm left with 3 on that side. Last thing I need to do is I need to get x on its own. So I'm going to divide both sides by, oh, look at that, minus 3. Divide both sides by minus 3, and I end up with x equals minus 1. Okay, that has solved it. Now, I could test that by putting it into both equations and seeing if it works. But what I now need to do is, because I've now got my x value, I now need to put the x into it. So I'm now going to go, okay, that's good. Now sub x into equation to have 1. Let's put it into equation 1. So we've got y equals 2, and we're subbing in the x, 2 times minus 1, plus 3. So y equals 2 times minus 2, plus 3, y equals 1. So what have I done? I've found the x value by substituting in one of the equations into the other. Then once I've found that x value, I've then put it back into one of the equations. I could put it into either one of them. If I subbed x into 2, I would have ended up with y equals minus 1, which equals 1. So I would have got the same answer. But the reason I put that back in is because I needed to find the y value as well. So now, solve the pair. X equals minus 1, y equals 1 is my final answer. Those numbers are the only numbers that will work in both those equations. That is where both of those lines exist. If I drew it graphically, I would be there. Minus 1, 1. That's what I would have found. Okay, but we didn't do it graphically. I found it algebraically. So we end up with an x value of minus 1 and a y value of 1. So it's exactly the same as we've done previously, where we've found the coordinate, but this time we've just done it algebraically and we've found what the x value is and what the y value is. I hope that makes some sort of sense.